everyone, welcome to Wanies Academy. Today's topic is alkanes, the properties and combustion of alkanes, which is under chemistry. So I'll be taking you chemistry for today. Let's look at the aim of the lesson and objective. The aim is to help the students understand what alkanes are, their general properties, and how they undergo combustion as first. At the end of the lesson, you should be able to define alkanes, state some physical and chemical properties of alkanes, explain how alkanes bond during combustion, and also state the uses of alkanes. Now let's dive into the lesson. Alkanes are saturated hydrocarbons, meaning they contain only single bonds between carbon atoms. This is an example of an alkane. It has a single bond between carbon 1 and carbon 2. The general formula of alkane is CnH2n plus 2, where n is an integer. So let's look at an example. If n equals 1, let's substitute 1 for n in this formula. We have C1 H2 into brackets 1 plus 2. This will give us C1H4. So our final answer in this case is CH4. CH4, which is the first member of alkane. It is called methane. So we have other examples which includes ethane, propane, butane, and so on and so forth. Now, alkanes are sometimes called paraffins, and they form part of the fractions obtained from crude oil. Let's look at the physical properties of alkanes. The first one, they are colorless and odorless gases or liquid, except higher ones, which are waxy solids. So the smaller alkanes are usually colorless and odorless. They are insoluble in water, but soluble in organic solvents. Most of the alkanes does not mix with water. They don't dissolve in water, but they dissolve in organic solvents. Another physical example is their boiling point increases with chain length. When we talk about chain length, this is what we mean by chain length. Increasing chain length means increasing carbon atoms. Increasing carbon atom. This is an alkane with 5 carbon atoms, while this is an alkane with 2 carbon atoms. So with the increasing chain length of alkanes, their boiling point increases. The fourth one, they are less dense in water, so they float. Alkanes usually float in water because they are less heavy than water. Let's look at the chemical properties of alkanes. The first one is combustion. Alkanes burn in air, which is oxygen, to release energy. The next is substitution reactions with halogens. In the presence of UV light, alkanes react with chlorine or bromine. This is an example of alkanes reacting with halogens. If you still remember your halogens, chlorine, fluorine, bromine, they are examples of halogens. The next is cracking. Large alkane molecules can be broken into smaller and more useful alkanes. An alkane that has a 10 carbon atom, which is decane, it can be broken down to, this is the formula of decane. It can be broken down to hexane, which is C6, H14, and butane. Which is C4, H8. So alkanes, a larger alkane can be broken down into smaller and useful alkanes. Let's look at the low reactivity and inertness. It is also a chemical properties of alkanes. Alkanes are generally unreactive compared to alkenes and alkynes because they lack double or triple bonds. This is why they are called paraffins, meaning little affinity. The single bond in alkanes make alkanes less reactive, make alkane a low reactivity. Now let's look at the combustion of alkanes. Like we said under the chemical properties of alkanes are widely used as fuels because they bond to release large amounts of energy. Now we have two types of combustion. We have the complete combustion and the incomplete combustion. The complete combustion occurs when there is a sufficient supply of oxygen. When there is a sufficient supply of oxygen, in this case, the product that will be produced is usually carbon dioxide and water. For example, if methane reacts, if it bonds in the presence of oxygen, the product gotten is carbon dioxide and water. Carbon dioxide and water. But in the case of incomplete combustion, there is limited supply of oxygen. The oxygen that is supplied is very limited. So therefore, instead of carbon dioxide to be gotten, carbon monoxide or soot in the form of carbon will be produced and water. So this is an example of a complete combustion of water, complete combustion of alkane, and this CH4 reacting with burning in the presence of oxygen would give us carbon monoxide and water. So uses of alkane. Let's quickly look at the uses of alkane. Alkanes are used as fuels, just like your methane used in your cooking gas, propane and butane used in your LPG, that's your liquefied petroleum gas, octane used in petrol, kerosene and diesel used in engines and jets. Can you see the uses of alkane? Alkanes are also used as lubricants. They are used in industries to get solvents, to get detergents, and many others. Alkanes are also used in the cosmetic industry to produce petroleum jelly. That is the Vaseline you use at home. So with that being said, we've come to the end of today's class. Don't forget to click the subscribe button to follow for more chemistry classes. See you in our next class. Bye.